In this lesson, we'll talk about two important properties of derivatives, and we've outlined them here with red and blue. The first one states that the sum of derivatives is equal to the derivative of the sum. If we differentiate g of x plus h of x, we will get the derivative of g of x plus the derivative of h of x. The second one tells us what happens when we multiply a function by any real number. What happens to the derivative if we have a times g of x? The derivative of this will be a times g dashed of x. So only g of x gets differentiated. We will first start with the proof, so we see that this actually happens, and then see how we can use these formulas. So then for the first one, we want to show that the sum of the derivatives is equal to the derivative of the sum. We will remind ourselves what the derivative actually is. F dashed of x0, the derivative of f when x equals x0, was actually the limit when x tends to x0 of f of x minus f of x0 over x minus x0. We will use this to prove our first formula. We know that f of x is g of x plus h of x. So we will write this as limit when x tends to x0. Instead of f of x, we will write g of x plus h of x minus, instead of f of x0, we will write g of x0 plus h of x0 over, again, x minus x0. Now this is then equal to, we will regroup the terms. We will put g of x next to g of x0 and h of x next to h of x0. We will then get limit when x tends to x0 of g of x minus g of x0 over x minus x0 plus the second fraction that we get is h of x minus h of x0 over x minus x0. So what we did here, we split this one fraction into two by regrouping the terms. So then this is actually equal to, we can split it into two limits. Limit when x tends to x0 of g of x minus g of x0 over x minus x0 plus the limit when x tends to x0 of h of x minus h of x0 over x minus x0, which, surprise surprise, is the derivative of g in x0 plus the derivative of h in x0. And we started from the derivative of f in x0. This is valid for any real number x0. So then our formula works even when we're using x. To prove the second formula, we work exactly the same. So then I encourage you to try it, and we will focus now on how to use this. Well, let's see. We'll take the case of a function f of x, which is 3x squared plus 5x. We will remind ourselves what we've learned previously, the fact that the derivative of x to the power of n, where n is any integer, is equal to n times x to the power of n minus 1. We've also discussed that this applies also when we have x to the power of r, where r is any real number, but we only need to use x to the power of n, which is n times x to the power of n minus 1. So then these, what we have here, are polynomials which are basically sums of terms that are powers of x. So we want to differentiate f of x. We'll say the derivative of f will be, this is a sum of two terms, so then we can apply the formula. We can differentiate both of the terms, so it will be 3x squared, which we want to differentiate, plus 5x, which we will differentiate. Now 3 times x squared we want to differentiate, but we know now that a times g of x differentiated is a times the derivative of g. So we only need to differentiate x squared, because we will know that 3 stays unchanged. So then this will be equal to 3 times x squared differentiated. For now we write everything. Further down the road we will do this more quickly. And the second one is 5 times x differentiated. If we differentiate x squared, we're using the formula x to the power of 2 differentiated will be 2 times x to the power of 2 minus 1, which is 2x. So then we have 3 times 2x, which is equal to 6x plus, and now we want to differentiate x. We can consider that x is to the power of 1. Differentiated will be 1 times x to the power of 1 minus 1, which is 0. 1 times x to the power of 0 is actually equal to 1. So we will have 5 times 1, which is 5. So then the derivative of f of x, which is 3x squared plus 5x, will be 6x plus 5. Let's try another function and see if we can work more quickly. F of x will be 6x cubed minus 3x squared plus 4x. Okay, we start to differentiate f of x, and we will know that this means differentiating every term it has. There's 3 terms. When we want to differentiate the first term, 6x cubed, we will only differentiate x cubed, and we know that x cubed differentiated, we use the formula, is 3 times x to the power of 3 minus 1, which is 2. So it will be 6 times 3x squared, which is 18x squared. Next, we take the following term, 3x squared. We know that 3 will not change, it will be multiplied by what we get after differentiating x squared. X squared differentiated means 2 times x to the power of 2 minus 1, which is 1. So then it will be 3 times 2x, which is 6x, plus 4x, which means 4 times x, so we will only be differentiating x. X differentiated, we bear in mind that it means x to the power of 1 differentiated, which will be 1 times x to the power of 1 minus 1, which is 1 times x to the power of 0, and anything to the power of 0 gives us 1, so this is 1. 4 times 1 is equal to 4. So we've differentiated using a combination of the two formulas. These two properties make it faster for us to differentiate, combined of course with the formulas for derivatives that we are starting to learn. More exercises to come in the following lessons.